move to our final speaker, which is Stavroula Panagiotidou from Technical University of Crete. And she will present her research on using satellite and geospatial data to improve ESG reporting and sustainability assessment in the energy and mining sectors. Stavroula, the floor is yours.
Okay, hopefully now you can hear me.
Yes,
hello everyone. Good afternoon. I'm Stavroula Panagiotidou from the Technical University of Crete, and today we will talk shortly on satellite and machine learning applications for ESG reporting or assessment in mining and energy industries. That's a short agenda for today. Let's dive into it and let's start by what actually ESG is, what it means, and when it started. So the story begins with the corporate social responsibility, or as it's known, CSR, back in the 60s and 70s, when companies started talking about ethics, philanthropy, and their role in society. It was voluntary, and it was about the intentions that the companies had. As globalization and environmental disasters occurred, the focus shifted. So terms like sustainable development came up. And then in 2004, we came up with the term of ESG, which stands for Environmental, Social, and Governance, as a financial framework. So for the first time, we can say that we measure sustainability in investment decisions. As you can see, some examples for the environmental can be the greenhouse gas emissions or the air quality. For the social part, we have the worker health or the diversity in the workforce. And for the governance, we can have the board composition, the ISO compliance of the company. But we will go now to the ESG paradox. So as you can see, 96% of the world's largest companies publish ESG or sustainability reports. You've probably seen most of you, some of them. They are like hundreds of pages. You have seen them for sure. And we see that the investments in this sector are increasing, and we have $40 trillion investments, but only one in three investors actually trust this data. And why? Because ESG doesn't suffer from lack of information, but from lack of verification. Most of the data that these reports have are self-reported sources or from external auditors. So there is really a lack of trust in this, and there we have phenomena like the greenwashing that you probably have been familiar with. So here is like the ESG ecosystem and the regulations behind it. You can see that is incredibly crowded. We have data providers, auditors, different frameworks, different benchmarks, different rating agencies, and all of them use different methodologies, different indicators and standards. So we see that it is a really grown field, but there are a lot of gaps between each framework and its rating system. And also we have the regulations and the directives that include the ESG, that there is the EU taxonomy, the Sustainable Finance Disclosure Regulation, the Corporate Sustainability Reporting Directive that you might be familiar as well with, and the Corporate Sustainability Due Diligence Directive. All of them are connected, and they aim to make the ESG more transparent and more comparable. So what is the missing link? If it doesn't lack from data, it lacks from verification. But what is exactly missing? We will answer that with two simple questions, and is the where and when. So in a report we can see reduced emissions, but where this emission had occurred and now they are reduced, or the biodiversity protection, for how long it has been protected, or in which scale, and what scale. In other words, they lack the spatial and the temporal dimensions. So for those that you might be not familiar with the term of Earth observation, or EO, it refers to the collection, the analysis, and the interpretation of data about the Earth's surface, atmosphere, and oceans. And it uses satellites, airborne sensors, drones, or ground-based instruments like the IoT that you might, the Internet of Things that you might know. These systems capture physical, chemical, biological parameters. And what makes it so powerful, of course, it's objective. It's just images from satellites, as you can imagine, or from drones. It's repeatable. They often occur every 1 week or 2 weeks, or daily sometimes, and they are comparable. So an Earth observation system is actually a system that is combined from satellites and sensors, the ground stations, and the in situ networks, and the geospatial analysis back when the data occurs. So why we chose the mining and industry and energy industry for my research is, first of all, from my background, I'm a mineral resource engineer. And of course, the most important reason is that these two sectors are between the intersection of the economic growth and the environmental responsibility. They are critical for the industrial and development, the global development, the digitalization right now, the energy transition. But on the other hand, they have a very high environmental and social footprint. So we need measurable, transparent data. So some example of how Earth observation can be applied in the ESG reporting. We can start with the environmental pillar, where we can use satellites like the Sentinel-2, for example, or the 5P to track the land use and the deforestation. In this way, you can verify if the company's biodiversity or reforestation claims are visible actually on the ground. You can track emissions from the Sentinel-5P for the Tropomi instrument that you might know, I don't know. And you can make measurements like the carbon dioxide on the nitrogen or the methane. So for the social dimension, the Sentinel-P, as I've said, can track the air quality. So this is really important for the workers' health. And for the governance, I mean, the use of something that is so transparent is already a plus for company. So I will show you now some examples of what is actually a satellite image and what you can track. So on the top row, we actually see how satellites see different types of deforestation, from small scale on the left for some agricultures to large scale and logging roads and the gold mining and the right side. We see that the partners are derived from the optical imagery. So mainly these are from the Sentinel-2. By analyzing actually changes in the vegetation indices and the surface reflectance. So you can see how different it is with the red color. In the bottom section, we have an example of air quality mapping from Sentinel-2 and Sentinel-5B data, where we can see the NO2 concentrations on the ground. The lower heat map show the predicted concentrations from the combination of Sentinel images and machine learning models, and that's a resolution of 100 meters. So this approach doesn't just reproduce the existing station data, but it can predict also the air pollution in areas that no ground sensors are there at all. And on the right side, we have the commercial data result, where they detected 8 methane plumes over a natural gas field in Turkmenistan. And they use hyperspectral sensors that capture the emissions that happening, and they weren't detected in real time from the site operators. I have another example here from Rossi and colleagues that use a geospatial methodology, which they call the Open Geospatial eScore framework, where they create an index based on different data that you can observe from Earth observation. So they observe, for example, here you can see the area of interest, which is a coal mine in Siberia. Here you can see in the second map the anthropogenic areas that occurred. And in the third one, you can see the water pollution. So they've come up with a way to, to calculate these and make these numbers actually, and they combine them in a very complex but very useful system to take a score out of it and see how the mining side scores on the environmental pillar of the ESG. So my approach comes from the question of how can we quantify the transparency of sustainability claims using this type of data. So the idea is to combine the company level disclosures. I don't believe that we can get rid of the traditional ESG reporting and actually just add another parameter, the transparency score, which will be a composite indicator that evaluates how much of a company reported environmental and social performance is observable, verifiable, and consistent with what we can see from our data. So, for instance, if a mining company reports 80% of rehabilitation of a degraded land, we can use a couple of indexes like the NDVI time series from a Sentinel-2 to check how much vegetation has regrown. Its data set in this case will be used to to compute the transparency score that will express how observable, verifiable, and where all of this happen. It will not be just one number. It will be something that will be shown in a map. So the future, we have some challenges, of course, as you can understand. It's a very complex topic. And it's not simple. First of all, we have the institutional and governance side. So there is no standard method at this moment that connects the satellite data with the ESG frameworks that are currently being used, like the GRI, the CSRD. And even though they are incredibly powerful, the Earth observation is not yet recognized as an auditable evidence under the Corporate Sustainability Reporting Directive. So there is this gap. Also, we have some technical issues, satellites can be useful on an asset level for a company. So, and also we can track them all the time, like not all the time, when a satellite takes an image actually from a site. But companies right now care about the corporate level for all of their assets, and they usually publish annual reports. Educationally, there are some challenges because we're talking about actually two different sciences, one the geospatial science and one about the finance and sustainable finance aspects. So we have to be trained into different fields to can interpret the geospatial data correctly. But seeing the future, we can be optimistic. We have new technologies coming up that for sure will help this grow. We can use different types of sensors, different type of field of data. We can build the capacity of our ESG analysts and auditors. Hopefully there will be some policy integration. And now about the SDG 12 alignment of my research, I think it's very obvious about the field of interest. And also, I think it's important that, yes, we can have responsible consumption production, of course, and we can measure that in a way. And we can have responsible reporting as well as part of it. Using the satellite data to see the environmental performance, the analysis, the machine learning to detect and predict the impacts. We can verify all the results from the sustainability reports, and we can, build a transparent environment for everyone that will include also the society, so the reports can be more friendly to them as well. So that's me. And I'd like to close with that. Sustainability is not declared, it's observed. In other words, it's not about what anyone can say in the reports, but about what we can actually see happening in the ground, or in my case, from space. So thank you, and I'm happy to take any questions.
Thank you very much, Stavroula, for your inspiring presentation, and then for demonstrating how data-driven approaches can strengthen ESG assessment and also support sustainable decision-making in industry. Yeah. Are there any questions for Stavroula? We have a few more minutes to go into discussion. Again, you can either put your question in the chat or just raise your hand. Yes, Michael, go ahead.
Thank you. Thank you for the question, Mr. Labutakis, Professor Labutakis. So we have thought about it, and it can work in multiple ways. So, for example, this can be used a regulation tool for those that want to track the reports of the companies. So they can use it and see. So is it verified or not? Also, it can work as for the companies to track their progress till they reach the annual report stage. So they can like have monthly reports verified by the Earth observation data to see if they are going to cut their goals, for example, to reach their goals. There isn't like somewhere that you can report this, of course, and I don't think that it can be 100% accurate because of the scale, and there are different spatial resolutions, but still it can be a good tool, an extra tool.
We received a question in the chat from Sibisanu Remus. Do you think if using AI will automate the process furthermore?
Yeah, for sure it could automate the process. It will be, I think, the next thing from my point of view, because there is so many data time series that can be processed quickly, but of course you have to take a look to verify your results, because you can't play with it.
Okay, thank you. Are there any more questions for Stavroula? I was wondering, you were mentioning the different parts of ESG, like environmental, social, and governance. When you compare those, and also within like these parts, which indicators are like most effectively captured using satellite imagery, and which ones are not so much? You see like lots of differences.
Yeah, we can all mostly work on the environmental pillar because it's what we see. The social also, some parts can be measured, like for example, if a new site is getting constructed, you can see how it affects the society, for example. But yeah, it's mostly on the social, on the environmental part, and of course, it only can add. It can also only contribute to the other pillars, not be a tool for assessment for the S&G.
Okay, thank you. All right. Yes, Luke. You have another question or a remark, maybe.
Thank you very much. Thank you for the presentation. Very interesting. This is a topic close to my heart, so it's very, very much appreciated. My question is about data bias. I've done a little bit of stuff with satellite data in the past, and of course, the problem with it often it picks up weather very well, good for cloud cover. If we're trying to check companies or institutions or whatever, how good they're providing things, depending on how much cloud cover they have, might be how easy, depend on how easy it is to check whether they're saying what they're doing actually what they say they're doing. I wonder how then you would take this into your consideration if then you only have one glimpse of it out of a data set of 60 days, as opposed to other places if it's in beautiful sunshine all the time, you can easily see, and any small little issue you can pick up super quick. So I think you could plot it nicely on the Earth, on the globe, where it might be easier to measure and where it might be slightly more tricky based upon just weather. But thank you.
Yeah, thank you for the question. I think this might be a challenge because here we are in Greece, so I'm not thinking of this aspect so much about the cloud coverage of the data, but it's a good one. And you have to take it into consideration. And I mean, it depends on what you're looking. If you are not very worried about the monthly ones. I think if you have some luck, you can have good results for an annual base. For example, if you want to see the land degradation, I think you will get a glimpse. And also there are commercial satellites that could solve this problem, that you can like order where you want them and when, so you can have some images from that time. So that could help a company.
Thank you very much for your answer.
Thank you for the question.
Okay. If there are no more questions for Stavroula, then I would like to thank our speakers of today, Nina, Arslan, and Stavroula, for your engaging presentations, and of course to all participants for your active questions and attention, participation. If you have any final questions, feel free to raise your hand or write in the chat. And if not, on behalf of the EURECA-PRO Doctoral School team, we would like to thank you all for joining us today. Yeah, we hope that this seminar has inspired some new ideas or connections maybe. And then I can end the session with wishing you a wonderful evening. And we also look forward to seeing you at our next online seminar, which will probably take place in February. But we will keep you posted when we have like final date and program. Thank you very much, and have a nice evening.
Thank you. Bye.
Thank you very much. Have a nice evening.
Bye-bye.
Bye.